Good morning, Morton Ranch, and welcome to Chapter 2, Section 5, Zeros of Polynomial Functions. At this time, pause the video to copy down all these notes. Now, looking at our example, we're going to find all the zeros. Well, to find out how many roots I'm going to have first, I have to know the degree of the polynomial. You find the degree by taking the highest exponent in the function. In this case, it's the 3. So that means I have 3 possible roots. Then we want to decide what kind of roots f of x will have using Descartes' rule of signs. In other words, we want to find out how many positive roots I can have and how many negative roots I can have. Okay, let's start with the positives. We just write down our function x cubed minus 5x squared minus 22x plus 56. Okay, I just go through and look at my sign changes. The first term is positive, the second term is negative. There's a sign change. The second term is negative, the third term is negative. No sign change. Okay, then I looked at my last two. Those two are different signs, so I have 2 sign changes, which means I count up to 2 by 2 starting at 0. So 0 or 2. I have either 0 or 2 positive roots. Now I want to check to see if I have any negative roots. To do that, all I have to do is put in negative x for where x is. So that's negative x cubed minus 5 negative x squared minus 22 times negative x plus 56. Okay, if I cube a negative number, it's going to stay negative. So the first term is negative. The second term, when I square a negative, it makes it positive, but since it's being multiplied times a negative 5, it's still negative. So the signs are still the same. Now, when I have negative 22 times negative x, that makes that positive 22. So from here to here, I have a sign change. Now, this was positive, and the last one is positive, so I have no other roots. So that tells me I have 1 negative root. Now that we have the total number of roots and what type they're going to be, we want to find out all possible rational roots. And we do that by taking the constant and finding the multiples of that constant, which are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 7, plus or minus 8, plus or minus 14, plus or minus 28, and plus or minus 56. Okay, we will divide all of those by the leading coefficient. And the leading coefficient is the first coefficient when your function is in order. So our leading coefficient is 1. So we'll divide all of these by plus or minus 1. Okay, finally we use synthetic division to test the possible rational roots. Well, let's go ahead and start with 1. So I put my 1 out in front, write out my polynomial by coefficients, so that's 1, negative 5, negative 22, and positive 56. Okay, I bring down the 1. 1 times 1 is 1. Negative 5 plus 1 is negative 4. Negative 4 times 1 is negative 4. Negative 22 and negative 4 is negative 26. 1 times negative 26 is negative 26. And that's 30. Well, the 1 didn't work because I do have a remainder. That means the function at f of 1 is equal to 30. So I'm going to move on to my next one. I'm going to go ahead and try 2. So I set up 2. and 1, negative 5, negative 22, and 56. Okay, I bring down the 1. 2 times 1 is 2. Negative 3 plus 2 is, or negative 5 plus 2 is negative 3. 2 times negative 3 is negative 6. Negative 22 and negative 6 is negative 28. And 2 times negative 28 is negative 56, which gives me a remainder of 0, which tells me that the 2 is a factor. So now I have a quadratic left because I know I started with a cubic, so I go down 1 degree, so that's going to be x squared minus 3x minus 28 equals 0. Now, I can easily factor this one. If I couldn't, I would use the quadratic formula. But this factors as x minus 7 and x plus 4, which means my two roots are positive 7 and negative 4. So now let's put all of our roots together. We know we had the 2 that we found by doing synthetic division, and we found the 7 and the negative 4 by doing factoring. So my possible roots are negative 4, or my roots are negative 4, 2, and 7. Well, that fits exactly what we said. We said we would have one negative root, and we had a possibility of 2 positive roots. Okay, let's look at another example. Again, we want to find out how many roots, so we find the degree of the equation, so that is 3 roots. Now we want to find the type of roots. Well, I'm going to speed this up a little bit and just look at the signs. That's a positive, that's a negative, that's a positive, that's a negative. So I have a sign change here, I have a sign change here, and I have a sign change here. Which, when I have an odd number of sign changes, I start with 1. So I have a possibility of 1 or 3 positive roots. These are my positive roots. Okay, now we do the negative. Okay, if I put in a negative x for x cubed, that's going to make that negative. If I put a negative in for x squared, that's going to still keep that term negative. And if I put in a negative for x, that's going to make that negative 2x. And, of course, the sign for my constant is negative. I have no sign changes, so I have 0 negative roots or solutions. Now let's look at all of our possible rational roots. Well, I do the multiples of 6, which are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay, and again we know we'll divide that by the leading coefficient, which again in this case is 1, so that's plus or minus 1. So I have 1, 2, 3, and 6, both positive and negative roots to look at. Let's go ahead and just start with 1. So let's do 1, and that's 1, negative 3, 2, and negative 6. Bring down the 1. 1 times 1 is 1. That's negative 2. 1 times negative 2 is negative 2. 2 and negative 2 is 0. 1 times 0 is 0, and that's negative 6. Well, that one didn't work. So, let's go up the chain. Let's try number 2. So, we put in 2. My coefficients are 1, negative 3, 2, and negative 6. Bring down the 1. 2 times 1 is 2. Negative 3 and 2 is 1. 2 times 2 is 2 times 2 is, oh, excuse me, that's negative 1. 2 times negative 1 is negative 2. That's 0. 2 times 0 is 0. That's negative 6. Well, that one didn't work either. Let's keep going up, though. So let's try the next one, which is 3. That gives me 1, negative 3, 2, negative 6. Okay, I bring down the 1. 1 times 3 is 3. Negative 3 and 3 is 0. 3 times 0 is 3. 2 plus 3 is 5. 3 times 5 is 15. I need to go back and look at that problem because I made a mistake. When you multiply 3 times 0, it's 0, not 3. So let's fix this up. And let's try again. 3 times 0 is 0. 2 plus 0 is 2. And 3 times 2 is 6. Negative 6 and 6 is 0. That leaves me with x squared plus 2 equals 0. Well, that's going to be x squared equals negative 2. So that's not rational. So that's not part of my roots because I'm looking for rational roots. So the only solution that I have is positive 3. That is my final answer. Okay, let's look at one more problem. The reason why I want to look at this one is because the leading coefficient is not 1. Again, we look at the degree of the polynomial, and it's 4 this time, so that means I have 4 roots. Now, when I say roots, that doesn't mean all of them are real or rational roots. I could have some complex roots, but I'm not worried about those because I'm not going to be able to graph those. Now we need to find the types of groups, so I'm going to look at the signs. So this is plus, this is minus, this is plus, this is plus, this is minus. So I have a sign change here, I have a sign change here, and I have a sign change here. So that means I have 3 sign changes, or 1 or 3 positive roots. Now, I'm going to go through and change all those x's to negative x's and just write down the signs. If I put a negative in for a x to the 4th, it's still going to stay positive, so the sign of the first one is going to be positive. If I put a negative x in for x cubed, that's going to make it negative, so a negative 15 is going to be positive. If I put a negative in for the x squared, it's going to remain positive. If I put a negative in for the x, it changes the 15 to a negative 15, which changes my sign, and then my last sign is negative. I only have 1 sign change. So that means I have 1 negative root. Okay, this time our possible roots are going to be just a little bit different. Our multiples for negative 25 are plus or minus 1, plus or minus 5, and plus or minus 25. Now, we also have to think about the roots of the coefficient. Now that the leading coefficient is other than 1, I have the multiples of plus or minus 1 and plus or minus 2. So you'll need to write out all of those possible roots. I have plus or minus 1, plus or minus 5, plus or minus 25. Now I go back and divide through by the 2, and that's plus or minus 1/2, plus or minus 5/2, and plus or minus 25/2. Those are all my possible roots. Well, let's go ahead and start out with 1. It seems to be an easy one to start with. 1's my first divisor, and I've got 2, negative 15, 23, 15, and negative 25. Okay, I bring down the 2. 1 times 2 is 2. Negative 15 and 2 is negative 13. 1 times negative 13 is negative 13. 23 and negative 13 is 10. 1 times 10 is 10. 15 plus 10 is 25. 1 times 25 is 25. and that gives me a remainder of 0. So 1 is a root. Well, I can't factor yet because what's left is a cubic, so I have to use synthetic division again. Well, I use the last coefficients that I have, 2, negative 13, 10, 25. Okay, since 25 is the constant and 2 is the leading coefficient, my possible roots are still the same. Well, I'm going to go ahead and try a negative number this time because it said that I had one negative root. So I'm going to try negative 1. So I bring down the 2. Negative 1 times 2 is negative 2. Negative 13 and negative 2 is negative 15. Negative 1 times negative 15 is 15. 10 plus 15 is 25. And negative 1 times 25 is negative 25. And that gives me 0. Okay, now that gives me a final quadratic of 2x squared minus 15x plus 25 equals 0. Now, using your favorite factoring method, you can factor this as x minus 5 and 2x minus 5. Okay, that gives us the two factors of positive 5 and positive 5/2. Okay, so that tells us that our roots are 1, let's start with the negative. Negative 1, 1, 5/2, and 5. 3 positive, 1 negative. And thank you. Enjoy your work and talk to you soon.